In this video, I am going to explain the different kind of configuration parameters which influences the results predicted from generative AI model for next word prediction. Before starting, let me give you my introduction.
Welcome to AD Academy. The main motto of this channel is AI for Aam Janta. My name is Dr. Ayan Devnath. I am an IIT Delhi alumni and Fulbright research scholar at Harvard University. I have total 9+ years of experience in the field of artificial intelligence, deep learning, machine learning, NLP, generative AI. Let's watch this video. Welcome to my metaverse.
If you have used different kind of LLM, that is large language model, from Hugging Face website or from AWS, then you might have encountered this kind of configuration parameters. One point you should note that the configuration parameters are different from that of the training parameter. Training parameters are the learnable parameter which are used when you are training the generative AI model, but configuration parameter are used or invoked when you are doing inference. These are the main top 4 configuration parameters: maximum new tokens, sample top K, sample top P, and temperature. Max new token is one of the easiest parameter to tune. Maximum new token is the maximum number of tokens a model can generate as output in completion. For example, this can be 100, 150, 200. When the model is predicting, the output goes through softmax output layer and then the next word gets predicted. So it can predict a maximum of 100 tokens if max new token is 100. Similarly, it can also predict maximum 200 number of tokens if the maximum number of token is 200. But it is not necessary that it will predict 200 tokens. It might happen that it will predict, say, 50 tokens or 50 words, and after that it gets an end of sequence token. So it will stop after 50 tokens and it will not generate 200 tokens. It means that maximum number of token is 200, so the model can generate maximum 200 number of tokens, but as soon as it gets end of sentence token, then it will stop. Here as an example, it is predicting 50 tokens and then 51 token is end of sequence token, so it will stop there, but maximum capacity is 200. The output from the transformer softmax layer is a probability distribution across the entire dictionary of words that the model use. Say for example, I have given few words and the corresponding probability. Now imagine that this is a list that carries on throughout the whole complete dictionary of the words that the generative AI has learned on and has the ability to give you prediction. Now while doing the prediction during the inference time, there are two methods by which you can select which will be the next word. One method is greedy decoding. It simply takes the word which has highest probability. So in this example, the next word prediction will be milk because it has highest probability 0.2. So the next word milk will be predicted. This technique is used for short predictions or short generations. This technique has some limitations, that this method is susceptible to repeated word generation. To avoid this limitation, that is repetition of the word generation, we use another method which is called random sampling. So in random sampling, randomly a word is taken as an output for next word prediction. It doesn't matter what that word has probability. So the problem is that it can generate any word. To become creative, this is very helpful that it can generate any word, but sometimes it might happen that it is not generating a word which is actually making some sense, because it is generating some next word randomly. That can be a random word and it doesn't make sense. So to control this random sampling, there are techniques like sample top k and sample top p. It means that if you use sample top k and sample top p, then the randomness will be less, and thus the next word prediction will make a sense. If you make top k value as 2, it means that out of all the probability, the top two probabilities, like where the probability values is higher, so those two words will be considered. For example, here milk is having probability 0.2 and powder is having probability 0.1, and rest of all other words having lower probability. So the top two probability words are milk and powder, and thus these two words will be taken into consideration, and out of these two words randomly any word will be chosen. Now if you choose the value of p equals to say 0.3, then those words will be chosen whose cumulative probability will become that p value. So here if you choose p as 0.3, then the top words whose probability, or rather whose cumulative probability, will become 0.3. So here the word milk and powder will be taken into consideration because their probability 0.2 and 0.1 will sum up to p 0.3. Now the fourth parameter is temperature. Broadly speaking, higher the temperature, the higher the randomness, and lower the temperature, lower the randomness. The temperature value is a scaling factor that is applied within the final softmax layer of the model that impacts the shape of the probability distribution of the next token. Let me give you an example. So here in the left hand side, I have taken words and the probability distributions. Now if the temperature is less than 1, then the peak is very narrow. It means that it is a strongly peaked probability distribution. If you choose the value of temperature which is less than 1, then the randomness of choosing the words will be very less. It means that those words whose probability is higher, only those words will be chosen, and the window for the randomness is very less, and thus very few words will be considered, and that will be randomly chosen. But if you choose value of temperature greater than 1, then in that case the probability distribution will have a flat bottom. It means that the window for choosing the word is large, and as a result the randomness is more, and more probability and more number of words can be chosen. So here in this example, in the right hand side, the word powder, cake and soap can be taken into consideration, and out of which randomly any word will be chosen. But if the temperature is less than 1, then the window is very less, and less number of word is taken into consideration. Say here for example only the word cake will be taken into consideration, and that cake will be the next word prediction. Thus these are the four important configuration parameters which you should keep in mind for next word prediction in case of generative AI during inference, and you have to tune these configuration parameters so that your model will work better in your use case. See you soon in my next class. If you like this video, then kindly share this video with all of your data science enthusiast friends who is very much enthusiastic in learning about generative AI.